Welcome back, chat. We're going to skippity on into this right now. I can feel the eyes rolling, and I love it, guys. Okay, so we're going to jump right in with an example. And again, if you're watching this video, we're using calculators for these. You're going to be discussing with your groups. I'm going to get 3 examples up on the board for you, or 3 different functions. And your guys' job is going to be to try to help me figure out what are these limits. So we're just going to say some limits. Some limits. All right, so A, B, and C is what we have here, and I'm going to give you no guidance because I want you guys to figure it out on the calculators. The first one we're doing, and I'm going to make somebody read this to me. Dolan, will you read me just what I've written there, just this part? Okay, so super weird order, but I think you're technically correct, which is the worst kind of correct. The limit as, what happens? X approaches 0. And you're right, Dolan. You said as x approaches 0, the limit of the function is. I've never heard anybody refer to it that way, but I would not count you wrong for it. But it's normally the limit as x approaches 0. Okay, so our first one, we're going to get real crazy with it. It's a fraction. It's e to the x minus 1 all over x. On B, I'm going to quit reading it out loud, but I want you guys to look up, talk about A first, but I'll get all 3 of these up. Using your calculators somehow is all that we're looking at here. Praying in school, huh? I'm making it. I know, I'm making a joke. Okay. All right, wasn't funny. Does it count as a joke still? All right, I'm gonna give you guys about 3 minutes of time to use your calculators, talk with one another. There's a bunch of different ways to approach these problems. In fact, I don't even care if you're just talking with your group. If your group can't come up with anything but one idea, you're cool to talk with another group. But let's see where we wind up. I assume that walking around, this is where everybody started. I went to my calculator and I typed in the function. Okay, there's step 1, easy. Okay, once I have this, what I saw most people doing, which is completely valid, is you're just going to the graph. So I'm going to go back home and I'm going to go to the graph. I don't know why I went home, but here's the graph. Now, I don't love just trusting a graph, but if we look at this and I see that, yep, there's little tick marks, I think it's believable that that is 1. Now, this is not the only way. We don't have to just blindly trace the graph. It was, I think, Christina that said it, but it might have been Krina. Christina, what was your suggestion that you had?
The table, so diamond to F5.
Okay, so Christina went into the table, which I'm good with. Diamond F5. We see that we have a table and it's jumping by pretty big amounts. Now, what if I don't want it to jump like this? Like we're trying to approach 0, yeah? Well, it's not undefined. That doesn't make sense. Yes, ma'am. Okay, let's check it. So the table, how would we change the size of the table if we're trying to? Can I see it real quick? I'll just see if I can figure out what's happening. Oh, you graphed all 3 of them, which you can. But if I'm just going to graph, all I have is one of the graphs up. That's why yours looks crazy. Yep, which you can do all 3 of them at the same time, but it's going to get really muddled. Okay. Above F4 in yellow, what do you see? Above F4 in yellow, you have table set. Check it out. If we set this table, jumping by 1 is too much. What do you want to jump by if we're checking here? 0.2. Sure. Okay, I've changed it, and I went second F4, and I just changed my delta table, which is how much we jump, by 0.2. So now as I'm looking, here I am on that first function, and I'm getting closer to 0. Does it look like it's getting closer to 1 to you? 1.7 to 1.53 to 1.37 to 1.22. Yeah. Only arbitrarily what somebody told me. I said, what do you guys want to jump by? And I heard 0.2. I could have picked 0.1 or 0.05. Yep, as we get close to 0, because our limit is as x approaches 0. So to change the jump above F4, you'll see table set. If we click on that, we have where do we start the table? That's a table start, and then we have delta table. So like when I change mine right now, it's going to start at 0.2, but I'll go ahead and go up just so we can get closer to it. Let's say I start at 1, and now I'm jumping by 0.1. I hit save, and when I go back into my table, here's 1, and let's see, we're at 1.7, 1.6, 1.5, 1.4, 1.3, 1.2. Are we getting closer to 1 seemingly? Yeah. Now, when I actually get there, it dies because it doesn't work. What about from the other side? Are we getting closer to 1? 0.86 to 0.91 to 0.95. You have 3 functions. Okay, so let's check. Okay, here's my challenge for you. If you're okay with the table approach, that's awesome. On the graphical approach, what can we possibly do? Go back into your graph and see if there's a way we could do it there. So if we're here, I think we're getting the same values. We just have different jump. So what I want you to do is let's change how much our table changes by. So hit diamond table set. And then right now you're jumping by 0.25 and you're starting at 0. I changed mine to 0.1 just now. We had it as 0.1 and 0.2. Yep, so if you're 0.1, if you hit enter, and then enter one more, I was just hit it to make sure it saves. So now, as I'm looking at this, I'm getting close to 0 from one side. Does it look like the y values are getting closer to 1? As we get closer, 1.29. So it does there. How about from the other side? Does it look like it's getting closer to 1 as we get closer? Boom, and that's all we're doing. Okay, there was somebody else's idea that I heard here because we can use the table. I'm going to be honest, and I think that we'll all agree. Do you guys like using the tables to calculate them? Okay, we are not going to agree. I hate it. I think it's tedious. Blah. But check it out. If we go to the graph, there's all sorts of stuff we can do here. Somebody used F3, and I don't remember who it was. Somebody said we can trace it, and I just don't recall who said it. Somebody did. I know I heard it. You should take the credit. Like, that's a good call. I can trace the function. Check it out. As I look at this, all I did was I hit F3 because it said trace up top, and now my cursor's on the function. As I can see it's to the right of 0 right now. As I get closer to 0, if we look at these y values, what does it look like it's getting closer and closer to as we get really close? Does it look like 1? These are the same numbers that were just on my table, but now I don't have to open the table and try to make sense of it. At 0, it's undefined. It won't give me anything. What about as I'm from the left and I'm starting to get closer? So here I am at negative 0.75, well, I'm going up and down. What am I doing? Getting closer and closer. What is this y value getting closer and closer to? 1 again. So whether we see it on the table or we see it on the graph, we get the same value. Okay. I would legitimately like to not use either of these approaches, but these are the way that we're doing it for now. Okay, table or graph, which one's easier? Okay, so we're given different answers, which is awesome, and I'm totally good with that. In case somebody's not sure because you kind of zoned out for a second, here's my graph. I'm going to hit F3, that's all I do. And now it just tells me, here's your X value. It blinks, and I can move it left and right to see what I'm getting close to. Yes, ma'am.
I'm so sorry.
Don't. All right, so let me see your calculator, and we're going to figure it out as a class. Can I make your screen brighter? Okay. You hold diamond. That's what we figured out, right? Why is it not working? Holy cow, yeah, you're right. Hey, look at that. Now your screen is normal. All right, so let's check it. We're going to look at the graph first. Okay, so here's this graph. This, I mean, it looks a little different, but does it do the same thing? I think so. Now, I'm not convinced that it's quite the same. So if I'm looking here and I want to see like, oh man, okay, it looks a little different. What might be the next thing we check, do you think? I would check the y equals because this is the easiest place to get goofed up. We have e to the x minus 1 over x. That x looks funny, but I'm pretty sure that that's the right one. So that's okay there, right? That's a function we have typed in. Okay, anything else that could lead to our graph looking funny? The zoom. If we go to zoom and it looks like wonky, standard is your 10 to 10. That's a normal. I remembered as zoom 6. Zoom 0 is a good one that we'll use later. I'm going to hit zoom 6 on this one. And my guess is our scale was just a little bit different. And it's nothing that you did. It's the fact that these calculators are still set the way they were at the end of last year. Okay. Yep. The Zoom 6 is going to be like your best friend for a while. Okay. Do you guys want, let's see here. We'll look at another way to do them tomorrow. Okay. I lied. We're going to do it right now. Do I care that your calculator can do your math? No. But would I give you fancy calculators to do the math if I didn't want you to use fancy calculators? No, right? That'd be a waste of money. So one more option. I want everybody go to y equals for me. And then I'm going to go up and select this, and I'm going to copy it, which remember is diamond up arrow. So I went to y equals. It's highlighted here, and I'm going to diamond copy. We all have it. Diamond copy is the up arrow right here. Okay, we're going to go back to the home screen. Now, the other day we played around in the algebra thing, and we saw that it could factor, it can expand. I'm going to be honest, we're not doing algebra right now. What are we doing? We're doing calculus. So I'm not going to use the algebra tab at F2. I'm going to use the calc tab at F3. Of the options that you see once you hit F3, the calc tab, which of these do you think might be the one we're going to use? The limit. Number 3. Okay, check it out. We have our limit. Okay. Yep. If you want to try to type it in, you're going to be wrong. You can hit enter if you want. It's going to say error, too few arguments. And we're slowing down a little bit in the lesson because the calculators are brand new. Even if you've hit enter, go ahead and get your limit up again so that once you're in here, we're just going to go in and we're going to paste what we copied. Or you can retype it in, but I just copied mine. Do we all have limit and then the function that we copied? Does anybody not have this on their screen right now and you need me to back up? Okay, if you were to hit enter, and I'll hit enter, I'll put my right parenthesis, it's really important, but if we hit enter now, it's still not going to give me an answer. It's going to say too few arguments. Now, all that we've written right now on our calculator is limit of this function. There's a whole nother part that we write every single time. What's the other part? It's not just the limit of f of x. It's the limit as x approaches something. Okay, on this one, and on this calculator, this will always be the case. We have to tell it what it's doing. We're taking the limit of this function, and then we're going to use a comma, which is right above 9. So I'm inside my parentheses still. The limit of that function, comma, what variable are we dealing with? X. So I'm going to type comma x. And then last one, what value is this going to? 0. Now, the notation on the calculator is going to be kind of ugly. We have the limit, then the function, comma, variable, comma, to what? If you hit enter now, because the pretty print, it is going to hook us up. Is that what we were just asked to solve? Yes. And when they do it, they got 1. Did that agree with our table? Did that agree with our graph? Yes. Here's the deal. Half the AP test does not have calculators. We're going to learn how to do these without graphs and without tables. It's really handy, though, if you don't want to have to take the time to go to the back of the book to check an answer. This is super convenient. If all you do is just do this to answer all the questions, I might not know on your homework, but I guarantee that you're going to regret it on the test. Like, make sure you do it. We're doing them by hand. I just want you guys to know that these exist, and we'll start getting practice with it. Okay. Looking at the other two, the first one was 1. How about the next one? Sin x over x. Yo. Let me look at how it's worded in the book. Oh, it's in my notes, right? I would just say equals 1. The limit, so you can say the limit. So here's my notes that I'm working on right now. Sorry. The limit of this thing equals 1. Yep. Cool. On this one, whether you use the graph, the table, or the limit button, will you guys give me this value? Why 1? I guess never mind because you looked on the calculator. Why can't we just plug in 0? What's weird about it? You can't divide by 0. Dolan claims this is 1. Somebody second that. The limit as x approaches 0 of sine x over x. Seconded. Just in case, I'm just going to use this one. If we're just doing sine x over x, and I'll just clear it all out, we'll go ahead and go calculus. We'll do a limit at number 3, and it's sine x. Where on earth is my sine button? Second y. It's right here. So sine of x close the argument, over x. If I hit enter, why am I going to be wrong? Not enough arguments. Instead of a parenthesis, what do I need to put here? Comma, x, tell it the variable we're working, comma, where are we going to? 0. Just using this, and this is a pretty fancy limit, just so you guys know, it's a neat one. It claims that it's 1. Awesome. On your notes or in your notes, what I want you to do, and this is like legitimately, if I'm going to put equals 1 there, we'll do it here too. So this one was equal to 1. This one is equal to 1. And I'm going to put a star next to that one because that one will show up a bunch of times this year. Any gut feeling on the last one? Okay, say that again. Does not exist as a reasonable thought. We're going to try something. You guys are going to type it in, okay? We're all going to type in a slightly different one. You're going to do 2x over 3x. You're going to do 3x over 4x. The limit as x approaches 0 of the sine of 3x over 4x. You're going to do 4x over 5x, and you're going to do 5x over 6x. Yep, you're doing sine of 2x over 3x. 2/3, 3/4, 4/5, 5/6. You need parentheses around whatever the x in the denominator is. So I'm going to do a random one. I'm going to do 7x over 8x. Oh, but so I also got 0 there, Casey, but I think we made the same mistake. Parentheses around your bottom part, guys. If you only have 8x and then you don't use a parentheses, it's going to do over 8 and then multiply by x. It will kill it. You're going to get 0. It's going to be wrong. Okay, so just to show you guys, parentheses right here matter big time. If you don't have them, we have to have these because otherwise it'll have this over 8 and then times x. Can't do that one. But check it out. I used the sine of 7x over 8x, and I got 7/8. You used sine of 2x over 3x. What did you get? 2/3. You used 3x over 4x. 3/4. 4/5.
5/6.
I think it's going to be 5/6. So let's see. Yeah, x comma 0, and then just close your parentheses, and you're good. That was all you're missing. Boom. Okay, so we see that there's a pattern showing up, I think. What if it's sine of ax over bx? What is that going to shake out at us? Ooh, does your answer have a sign in it? It's just a over b. Yo, you forgot a right parentheses, my guess, at the end. So I see too few arguments. Oh, you forgot the comma.
4.
Before the x, right before the x. And you might have an extra set of parentheses. It's the hardest thing to learn with them is the parentheses. But I think if you put the comma there, it'll work.
I got sine 4/5.
You got sine of 4/5 or just 4/5?
Sine 4/5.
Oh, I see what's happening. So check it out. Sine of, let's see here. So always, always, always parentheses. And I know like it seems like it's such
I
a.
thought I did. Maybe I forgot.
No, and you're okay.
Was it just the one I was
So
missing?
too few arguments, and let's see here. Comma x comma 0. There we go. Yep. So I can tell that it was like this should have been the sine of 4x over like 5x in the end, but I can see that those were both stuck to the sign. So that's how I knew that there was an issue when I saw that one. But now it looks like we wanted to. Cool or no?
Yeah.
Okay. All right. Calculators, you think they're going to be helpful for you? For sure. Okay. Now, we saw some of this on the homework. We're going to try to blast through it real quick. Let's do some graphical limits. And let's see. We're about to start, and I lied to you guys apparently because we went to calculator mode, but we are so close to being done already. Let's see. I like that blue color. Okay. For our second part here, we're just going to look at some graphical stuff, and we're just going to give ourselves a nice formal interpretation of this. Graphical limits. You guys have done a bunch of these on the homework already, which is awesome, but we're just going to refine it and make sure we have it like as a solid, true math idea that we're going to be able to use. So some graphical limits. Now, on these, we're going to have 3 small graphs, and they don't have to be super duper fancy. Mine are going to be awesome. Or terrible. I'm still learning a program. Oh, I can move it. Hold on here. So they actually told me that the other program that I normally use is going to, like, it might have some vulnerabilities with, like, computer security, so maybe I can't use it. But I'm going to learn this new one. I hate the scales, but we're okay. All right. So I have these wonderful graphs just kind of hanging out. All I'm going to do is I'm going to put a spot on here that we'll call capital L. I'm going to put a spot over here that we're going to call C. And I'm going to do this on each of these 3 graphs. Now, the finger thing that we do where it looks like someone's just up here simping, that's what it's going to look like with this as well. But there's a reason we don't touch our fingers. And the real justification is coming here. When we calculate a limit, we only care about as it gets how close to that x value. Arbitrarily close. Do we need to be able to plug it in? I don't think so. So check it out. And really, we only needed the first quadrant, but I'm going to make this work. Let's say I had a function that came up to curved upward and hit L like this. The point was closed, and then it kept going. And this was F. So I just have a kind of ugly function here. Based on this graph, if we took the limit as x approached c of that function f, and I'm going to call it f of x, what does it look like it spits out as a y value to you guys? Red says L. Do you guys agree that that looks... Maybe you didn't. Somebody said L. Not took the L, but said L. What do you think this is? As I get really close, what are we approaching? So C is the x value that we're getting close to. I agree with you. What about the y value that we care about? L. From the left, it's L. What about from the right? Bet, bruz. So chat, what is it? L. Boom. Okay, let's get weirder. Let's have that same kind of looking function. We're going to come up here. Big old open circle. Then it keeps going on. In this situation, as I approach from the left, what is it? As I approach from the right. So do I care that it's defined there? No. As long as they point to the same y value, what are we going to say this limit is?
L.
It's L. Easy. Piece of cake. So the limit as x approaches c, f of x, once again, equals L. Draw me one that... Nope, I lied. We're going to do the last one. What if we have the same type of graph? And we'll just make it a big circle there, but it's defined here, and then it keeps going here. It's still L. We don't care at all about what happens at that whatever we're approaching value, other than we need to know what it is so we can get really arbitrarily close to it. But in all 3 of these situations, we have the same limit existing with the same value, even though these 3 functions are wildly different when we get close to that x equals c value. Okay, with your hands, show me the limit exists. Okay, with your hands, show me a limit that doesn't exist. That one's a weird one, but I like it. I wouldn't point up because I don't think you're going to have a function doing that. But as long as they're not meeting the same point, that's okay. It can be here. This exists. This does not. Which means for f of x, or the limit of f of x to exist, we require that what's true about the left and right limits? They're equal and they exist. So check it out. Last little statement that we're going to make here. The limit, and this, you could think about it with these graphs, but it doesn't have to be from these graphs. From as x approaches c of f of x exists. Now, I'm going to write if and only if, but I don't want it to be wordy. How on earth do we do that? If and only if the limit as x approaches c from the left of f of x equals the limit as x approaches c from which side, do you think? The left side has to match with the right side. And it turns out that when you get the left limit and the right limit to match, then we simply say that that is exactly equal to the overall limit. And you guys, I think, had some questions because I might have given you homework a little bit further ahead than we did. But either you dealt with it over the weekend and the homework went well, or we finished dealing with it this morning and it went kind of well also. Okay. We should look at one weird one that we're going to use Desmos for. And I'm not going to make you make a table for it, but I do want you to be aware of like that some weird things can happen from time to time. What we've seen up to now, and I can just do it on here. I don't need Desmos even. What we've seen, you guys are all here. Yeah, that's fine. Okay. Nope, that one's the one that's trying to die. Okay. In here, we've seen that we just get really close to the value. It's kind of like it's almost an asymptote that we're thinking about, and depends on the situation, but it doesn't have to be. Let's say that we had a wave function that had been dampened somehow, and eventually it got to just be so small that when it was kicking back and forth, and I'll fix that so it looks kind of realistic, it just gets so small that as it oscillates, it just does this, bouncing back and forth between positive and negative. And I can imagine that would happen, like it just gets smaller and smaller, like a spring maybe. As x approaches, I don't know, this value, what do you think this function is? The limit as x approaches c, right here, of that function. Any gut feeling? Why 0? Yeah, it's getting closer, right? Doesn't matter whether they come from the left or the right. Do we approach the x-axis still? It's okay if they oscillate weird. We're going to see weird ones that do that. You don't have to think about the whole behavior of the whole function. Just as you get really close to some particular value, just check there. There's some weird ones that we'll get with, but they're not here. Okay, we got 15 minutes. I don't think I have 15 minutes worth of problems for you guys. So theoretically, you should not have to take homework home tonight. But let's go ahead and find it. I will put up the correct solutions manual here in just a minute also. Wrong thing. So I'm just going to say add, right? Add. This is on page 86. This year, I'm going to make a change that is going to be annoying on my end, I think, initially, but probably for you guys. I don't want frillies anymore. When you hand them in out of your notebooks, I don't want your frillies. Do you know what I'm talking about? Okay, I don't know the real word for it, but if we all know what frillies means, then I'm cool with it. Okay, you're going to add problems 31, 35, 37, 38, 41. Last year, people started leaving frillier pieces with stuff falling off everywhere or torn more. Like, I don't know. I don't think it was you guys specifically. I don't remember. But, oh, yeah. We're going to look at our books real quick, too. Okay, you get to add those problems, 31, 35, 37, 38, 41, and the AP problems. We haven't talked about this. Using your textbooks, I want you to find me the page where the AP problems are so that I'm not going to have to write the numbers every time, but just see if you can find the problems that I'm talking about.